right, co-requisite material lesson number 2, in an attempt to get you prepared to take the co-requisite assignment in my stat lab. Let's review a few things. Back in co-requisite material lesson 1, we evaluated a function similar to this. I think the one we did back then had a square root. So anyway, what I would do here is I would square b. So b is -3, so -3 times -3 is a +9. Next thing, -4, and then I would multiply a times c. A is -2, c is 5. -2 times 5 is -10. Remember, I have to multiply before I add, so -4 times -10 is +40. Plus the 9 that comes down, so the final answer would be 49. Transitioning into a little bit of set theory. And the way this is read, when you see this big U, it's read A union B. Now the upside down U is read A intersect B. And what this notation represents in set theory is the union just means that we add every element, we combine every element that's seen at least one time in either set. So this is kind of like saying A plus B. So if I take A, it's 1, 2, 3, 4, 5. B is 3, 4, 5, 6. You can see that 3, 4, and 5 are repeated from A, so I don't need to include those. But I need to add 6 into the union of these sets, because again, I'm adding the elements. So A union B would be A, which is 1, 2, 3, 4, 5, plus anything in B that isn't already seen in A. So in this case, it would just be adding 6. Now the intersection of A and B is just the elements that occur in both of the sets. So you can see 1 doesn't occur in B, so we don't include it. 2 doesn't occur in B, we don't include it. 3 is in A and B, so we include it. 4 is in A and B, so we include it. And 5 is in A and B, so we include it. We do not include 6 because A does not include 6. So the intersection of A and B would just be the elements 3, 4, and 5. Now, preparing you to get into probability, and we see expressions like this a lot, where we take, this is actually called the expected value, but for right now, let's just think of it as E, is the sum of our x's times their probabilities. So you can see right here, 0 has a probability of 0.25, 2 has a probability of 0.33, and 7 has a probability of 0.42. For this to be a probability distribution, these numbers in the bottom, the probabilities, must add up to 1. And you can see that they do. So I think in creating these sums of x times p of x, I think it's important to get organized and put our information in a table. So the first thing I need to do is I need to do what's inside the brackets. So take the x times the p of x, which I did. 0 times 0.25 is 0. 2 times 0.33 is 0.66. And 7 times 0.42 is 2.94. Then I implement the summation. I add these up. I add up 0 plus 0.66 plus 2.94 to get 3.60. I cannot tell you, if I had $1 for every time I've seen students try to they do the order of operations wrong. They'll add up the x's and then add up the p of x's, and then they'll multiply those together. And that's the opposite order of operations here. Remember, we must do what's in the parentheses first and then add those elements. Next part is really, really easy. I think this is going to be a review for all of you. Just graphing inequalities. This comes it's kind of important to have this kind of tattooed to the brain when we get into confidence intervals. But just as a review, if we're looking at the solution set of x greater than or equal to -3, if I'm going to sketch this out by hand, I'm just going to put a number to the left of -3 and the number to the right of -3. Since it's greater than or equal to, I'm going to use a solid dot, solid circle, and then everything to the right of that, hence greater, is our solution set. Compare that to x strictly less than 2. Again, number to the left, number to the right. I have an open circle because 2 is not part of the solution set, but everything less than 2 is in the solution set. Up here, -3 itself is a solution. Down here, 2 is not because we're looking at strictly less than 2. And sometimes we get situations like this. In fact, a lot of the time we do. The reason we look at problems like this and this is because we see this when we get to confidence intervals. So this tells me that I need to look at the numbers that are greater than or equal to -3, but also strictly less than 5. So solid dot for obvious reasons, open dot for obvious reasons, in between -3 and 5 because that's as the problem states. So any number between here, between -3, including -3, all the way up to 5, but not including 5, 4.999999987, that's a solution. But 5 itself is not a solution to this inequality. All right, gang, that's all I got.